M4th. Replace carbon, sprint to wood, wind and sun, eliminating existing coal, oil. C12. Bottom line. 4th B, sprint to wood, wind and sun, eliminating existing carbon, coal. C12. Brown's details. Plan B involves a crash program to develop 3,000 gigawatts of wind generating capacity by 2020, 3,000 coal plants worth. This will require a doubling of capacity every 2 years, up from the doubling every 3 years for the last decade. It will mean 0.0001 gigawatt for every 2,500 of the world's projected 2020 population of 7.5 billion people. Denmark with 0.0001 gigawatt for every 1,700 people is already well beyond this goal. Spain will likely exceed this per capita goal before 2010 and Germany shortly thereafter. Requires the installation of 2 million 2 megawatt wind turbines, 65 million cars the world produces each year. At $3 million per installed turbine, this would involve investing $4.5 trillion over the next dozen years, or $375 billion per year. World oil and gas capital expenditures that are projected to reach $1 trillion per year by 2016. Wind turbines can be mass-produced on assembly lines. The idle capacity in the US automobile industry is sufficient, and the skilled, idled workers. Plan B, energy efficiency measures, from Plan October 2009. World electricity generation by source in 2008, and in the Plan B economy of 2020. Plan B, carbon dioxide emissions reduction goals for 2020. The world energy economy of 2020. Development of 5,153 gigawatts of new renewable generating capacity by 2020 versus 5,153 coal plants. Over half of it from wind. More than enough to replace all the coal and oil and 70% of the natural gas now used to generate electricity. The addition of 1,530 gigawatts of thermal capacity by 2020 will reduce the use of both oil and gas for heating buildings and water. Roughly 2/3 of this growth will come from rooftop solar, water and space heaters. 20th century belonged to oil, 21st to sun, wind, geothermal. Europe, new electrical generating capacity from renewable energy sources in 2006 exceeded that from conventional sources. First continent to enter the new energy era. US generating capacity from wind increased 27% in 2006. Texas, wind power that could yield 23,000 megawatts of new generating capacity, an amount equal to 23 coal-fired power plants. Note, seems that 1 gigawatt, 1000 megawatts, approximates 1 coal plant. 21st to sun, the wind, geothermal. China, some 160 million people now get their hot water from rooftop solar water heaters. Iceland, almost 90% of homes are heated with geothermal energy. Europe, 60 million people rely on wind farms for their electricity. Philippines, 19 million people get their electricity from geothermal power plants. 21st to sun, the wind, geothermal. This chapter addresses the challenge of harnessing renewable energy on a scale that will help reduce worldwide carbon dioxide, CO2, emissions by 80%. The first priority is to replace all coal and oil-fired electricity generation with renewable sources. This is not Plan A, business as usual. This is Plan B, a wartime mobilization, an all-out response proportionate to the threat that global warming presents to our future. We can expand renewable energy use fast enough, Restructuring of the energy economy will be driven also by the realization that the fate of our global civilization may depend not only on doing so, but doing so at wartime speed. Harnessing the wind. A Stanford team, the Earth's available wind energy would provide 35 times as much electricity as the world currently uses. China, with vast windswept plains in the north and west, countless mountain ridges, and a long coastline, all rich with wind, has enough readily harnessable wind energy to easily double its current electrical generating capacity. 3 states, North Dakota, Kansas, and Texas, have enough harnessable wind energy to totally satisfy national energy needs. Wind turbine output has increased 20x in the last 30 years. World leaders in wind capacity. Germany. 3 North German states now get more than 30% of their electricity from wind. Germany as a whole, it is 7% and climbing. United States, Spain, India. Denmark is the leader, at 20%. Wind expansion planned. Denmark is now looking to push the wind share of its electricity to 50%, with most of the additional power coming from offshore. They are looking at using wind as the mainstay of their electrical generating system and fossil fuel generated power to fill in when the wind ebbs. Among the emerging wind powers are China, France, and Canada, each of which doubled its wind electric generation in 2006. Critics against wind. Bird fatalities from wind farms are minuscule compared with deaths from flying into skyscrapers, colliding with cars, or being captured by cats, or the 50 to 250 species going extinct daily from carbon warming and earth rape. When some people see a wind farm, they see a blight on the landscape. Others see a civilization-saving source of energy. Among ranchers in Colorado or dairy farmers in upstate New York, the competition for wind farms is intense. A large, advanced design wind turbine can generate $300,000 worth of electricity in a year. Farmers, with no investment on their part, typically receive $3,000-10,000 a year in royalties for each wind turbine erected on their land, 1 to 3% share. Wind requires so little land compared with other sources of renewable energy. A corn farmer in northern Iowa can put a wind turbine on a quarter acre of land that can produce $300,000 worth of electricity per year. This same quarter acre would produce 40 bushels of corn that in turn could produce 120 gallons of ethanol worth $300. The turbines occupy less than 1% of the land in a wind farm, lets farmers harvest both energy and crops from the same land. Thousands of ranchers in the wind-rich Great Plains will soon be earning more from wind royalties than from cattle sales. Wind constrained by turbine manufacturing capacity. Wind is the centerpiece of the Plan B energy economy. Abundant, low cost, and widely distributed, scales up easily, and can be developed quickly. The Earth's wind resources cannot be depleted. Plan B involves a crash program to develop 3,000 gigawatts of wind generating capacity by 2020, 3,000 coal plants worth. This will require a doubling of capacity every 2 years, up from the doubling every 3 years for the last decade. It will mean 0.0001 gigawatt for every 2,500 of the world's projected 2020 population of 7.5 billion people. Denmark, with 0.0001 gigawatt for every 1,700 people, is already well beyond this goal. Spain will likely exceed this per capita goal before 2010 and Germany shortly thereafter. Requires the installation of 2 million 2 megawatt wind turbines, 65 million cars the world produces each year. At $3 million per installed turbine, this would involve investing $4.5 trillion over the next dozen years, or $375 billion per year. World oil and gas capital expenditures that are projected to reach $1 trillion per year by 2016. Wind turbines can be mass-produced on assembly lines. The idle capacity in the US automobile industry is sufficient, and the skilled, idled workers. Wind-powered plug-in hybrid cars. World desperately needs a new automotive energy economy, a new source of fuel. Foundation for this has been laid with two new technologies, the gas-electric hybrid cars pioneered by Toyota and advanced design wind turbines. Toyota Prius 46 miles per gallon in combined city/highway driving, compared with 20 miles per gallon for the average new US passenger vehicle, 60% less carbon, gas, oil. US could easily cut its gasoline use in half simply by converting the US automobile fleet to hybrid cars. Recharging batteries with off-peak wind-generated electricity will cost the equivalent of less than $1 per gallon of gasoline. This modification of hybrids, to run largely on electricity, could reduce remaining gasoline use an additional 60%, for a total reduction of 80%. Wind-powered, polymer composite plug-in hybrid cars. But this is not all. Amory Lovins, an energy efficiency pioneer, notes that substituting advanced polymer composites for steel in auto bodies can roughly double the efficiency of a normal weight hybrid without materially raising its total manufacturing cost. Thus, building gas-electric hybrids using the new advanced polymer composites, which are being introduced by Boeing in its new 787 Dreamliner jumbo jet, can cut the remaining 20% of fuel use by another half, for a total reduction of 90%. Plug-in electric hybrid/wind power requires no major new infrastructure. Network of gasoline service stations and the electricity grid are already in place. 2006 study, 84% of the electricity used by a national fleet of plug-in cars, pickup trucks, and SUVs could be satisfied with the existing electrical infrastructure, since the recharging would take place largely at night, when there is an excess of generating capacity. Variability of wind can be largely offset by integrating local and regional grids into a strong national grid, something that is needed anyhow to raise load management efficiency. Since no two wind farms have identical wind flows, each wind farm added to a large grid reduces variability. With many wind farms on a large grid, variability largely disappears. Another major source of stability. Shift to plug-in hybrids, since the vehicle batteries become a storage system for wind energy. With a smart grid, motorists could profitably sell electricity back to the grid when needed during peak demand. With their electricity storage capacity and backup tank of gasoline, buffers the variability of wind energy. Massive economic and emissions benefits. Rejuvenate farm and ranch communities. Dramatically shrink the US balance of trade deficit. Could cut automobile CO2 emissions by some 90%. Solar cells and collectors. There is enough solar energy reaching the Earth each hour to power the world economy for 1 year. Solar cells and collectors. Solar thermal collectors, widely used to heat water, are now also used for space heating. Collectors concentrate sunlight to boil water and produce steam-generated electricity. Assemblages of solar electric cells are used on a commercial power plant scale, with individual plants capable of supplying thousands of homes with electricity. Some 40 million rooftop solar water heaters in China. 2,000 Chinese companies manufacturing rooftop solar water heaters. This relatively simple low-cost technology is widely used in cities. It has also leapfrogged into villages that do not yet have electricity. For as little as $200, villagers can have a rooftop solar collector installed and take their first hot shower. Beijing plans to more than double by 2020. Equal to the electricity generated by 54 coal-fired power plants. Looks like each 800,000 heaters would replace about one coal plant. Once the initial installment cost is paid, the hot water is essentially free. Rooftop solar water heaters. Austria, Europe's leader. 15% of all households now rely on them for hot water. In some Austrian villages nearly all homes have rooftop collectors. Some 2 million Germans are now living in homes where water and space are both heated by rooftop solar systems. European Union has a long-term potential of developing 1,200 thermal gigawatts, about 1,200 coal plants worth of solar water and space heating, which means that the sun could meet most of Europe's low temperature heating needs. In industrial countries, these systems pay for themselves from electricity savings in fewer than 10 years. Solar cells, now doubling every 2 years. The estimated sales for 2008 of over 5 gigawatts will climb to 320 gigawatts in 2020. When a villager buys a solar cell system, that person is in effect buying a 25-year supply of electricity. Note the 19th of December 11. Headline today: an energy CEO projecting that rooftop solar will be cheaper than grid energy by 2060. Concentrated solar power uses reflectors with automated tracking systems to concentrate sunlight on a closed vessel containing water or some other liquid, raising the temperature as high as 750 degrees Fahrenheit to produce steam. California installed 0.354 gigawatts of solar thermal generating capacity nearly 20 years ago. Prominent among the regions with the solar intensity needed to profitably operate solar thermal power plants are the US Southwest, North Africa, Mediterranean Europe, the Middle East, Central Asia, and the desert regions of Pakistan, northwestern India, and northern and western China. Concentrated solar. Algeria, our potential in thermal solar power is 4 times the world's energy consumption. Solar thermal generation in sunny climates peaks during the day, when air conditioning needs and personal power demands are also peaking. Southwestern United States, a potential solar power generating capacity of 7,000 gigawatts of electricity, roughly 7 times current US generating capacity from all sources. Seems US electric total is 1,000 GW? Something wrong with these numbers. 80 gigawatts of this generating potential could be developed by 2030. We suggest a more immediate goal of 200 gigawatts by 2020. The 19th of December 11. Note, solar panel prices diving so fast that they may take up much of this slack. Energy from the Earth, geothermal. The heat in the upper 6 miles of the Earth's crust contains 50,000 times as much energy as found in all the world's oil and gas, not coal, reserves combined. Only 9.3 gigawatts of geothermal generating capacity have been harnessed worldwide. Because of the dominance of the oil, gas, and coal industries, which have been providing cheap fuel by omitting the indirect costs of fossil fuel burning, relatively little has been invested in developing the Earth's geothermal heat resources. Energy from the Earth, geothermal. Over the last decade, geothermal energy has been growing at scarcely 3% a year. An estimated 100 thermal gigawatts of geothermal energy, roughly 10 times the amount converted to electricity, is used directly without conversion into electricity to heat homes and greenhouses and as process heat in industry. The energy used in hot baths in Japan and to heat homes in Iceland and greenhouses in Russia. Plant-based sources of energy. Forest industry byproducts, sugar industry byproducts, urban waste, livestock waste, energy crops, crop residues, and urban tree and yard wastes. The bulk of the nearly 10 gigawatts in US plant-based electrical generation comes from burning forest waste. St. Paul, Minnesota, district heating system, waste wood, city of nearly 300,000 people. Combined heat and power plant using tree waste from the city's parks, industrial wood waste, and wood from other sources. 250,000 tons or more of waste wood per year, just under 1 ton per person. District heating to some 80% of the downtown area. Replaced coal, thus simultaneously cutting carbon emissions by 76,000 tons per year, disposing of waste wood, and providing a sustainable source of heat and electricity. Garbage can also be burned. Europe, waste-to-energy plants supply 20 million consumers with heat. United States, some 89 waste-to-energy plants convert 20 million tons of waste into power for 6 million consumers. Animal waste. US livestock and poultry production now concentrated in large facilities. Use of animal waste in anaerobic digesters to produce methane, natural gas. Methane produced in landfills. Crops. 2007 the world produced 13.1 billion gallons of fuel ethanol and 2.3 billion gallons of biodiesel. 50% of the ethanol came from the United States, A 33% came from Brazil, sugarcane. 1/4 of the biodiesel was produced in Germany. The other major producers were the United States, France, and Italy. Europe, with high goals for biodiesel use and low potential for expanding oilseed production, biodiesel refiners are turning to palm oil from Malaysia and Indonesia, where the clearing of rainforests for palm plantations is raising worldwide concern. Cellulosic materials, switchgrass, wood chips, wheat straw, and corn stalks into ethanol. Switchgrass and hybrid poplars would produce relatively high ethanol yields on marginal lands, but it likely will be another decade before cellulosic ethanol can compete with corn-based ethanol. Burning cellulosic crops to directly generate electricity is much more efficient than converting them to ethanol. United States could generate 110 gigawatts of electricity from burning crops such as switchgrass and fast-growing trees, roughly 10 times the current level. Worldwide use of plant materials to generate electricity could contribute 200 gigawatts of generating capacity by 2020. River, tidal, and wave power. Roughly 16% of the world's electricity comes from hydropower, most of it from large dams. Small-scale projects continue to be built. 2006 small dams with a combined 6 gigawatts of generating capacity were built in rural areas of China. The future holds the promise of in-stream turbines that do not need a dam and are thus less environmentally intrusive. Tidal generating facility. La Rani Barrage, with a generating capacity of 0.240 gigawatts, was built 40 years ago in France and is still operating today. South Korea is building a 0.254 gigawatt project on its west coast. At another site 30 miles to the north, engineers are planning an 0.812 gigawatt tidal facility. China is planning a 0.300 gigawatt tidal facility at the mouth of the Yalu River. New Zealand is planning a 0.2 gigawatt project in the Kapara Harbour on the country's north coast. Gigantic tidal projects are underway. India is planning to build a 39-mile barrage across the Gulf of Cambat on the country's northwest coast with a 7.4 gigawatt generating capacity. United Kingdom, several political leaders are pushing for an 8.6 gigawatt tidal facility in the Severn estuary. Russian planners are also talking in terms of 10 gigawatt tidal power plants. Wave power is a few years behind tidal power. Californian utility PG&E has filed a plan to develop 2.04 gigawatt wave farms off the state's north coast. Oil giant Chevron filed for a permit to develop up to 0.06 gigawatts of wave generating capacity nearby. Ireland has the most ambitious wave power development goal, 0.5 gigawatts of wave generating capacity by 2020, enough to supply 7% of its electricity. Outlook for hydro. 850 gigawatts, 850,000 megawatts, 850 coal plants worth approx. Of hydroelectric power in operation worldwide in 2006 will expand to 1,350 gigawatts by 2020. A 58% increase. China's official projections, 270 gigawatts will be added there, mostly from large dams in the country's southwest. 230 gigawatts in our projected growth by 2020 would come from a scattering of large dams still being built in countries like Brazil and Turkey, a large number of small hydro facilities, a fast-growing number of tidal projects, some of them in the multi-gigawatt range, and numerous smaller wave power projects. The World Energy Economy of 2020. Development of 5,153 gigawatts of new renewable generating capacity by 2020 versus 5,153 coal plants. Over half of it from wind. More than enough to replace all the coal and oil and 70% of the natural gas now used to generate electricity. The addition of 1,530 gigawatts of thermal capacity by 2020 will reduce the use of both oil and gas for heating buildings and water. Roughly 2/3 of this growth will come from rooftop solar water and space heaters. Plan B Energy Economy of 2020. Fossil fuel generated electricity drops by 90%. 5-fold growth in renewably generated electricity. Transportation sector, energy use from fossil fuels drops by some 70%. Plug-in hybrids, electric trains. Indirect energy savings. When coal is phased out as a power source, the vast amount of energy used to extract the coal, bring it to the surface, and transport it typically hundreds of miles by rail, to power plants is no longer needed. Some 42% of US freight is coal transported by diesel-powered locomotives. Electricity will be much more prominent. 2020 electricity will be the principal source of energy for cars. Trains' electricity will replace diesel fuel. Many buildings will be all electric, heated, cooled, and illuminated entirely with carbon-free renewable electricity. Smart grid. It gives consumers a choice, for example, between running a dishwasher during peak demand and paying 9 cents per kilowatt hour for electricity and running it at 3 a.m. using 5 cents electricity. Can shrink their electricity bills and benefit utilities by reducing the generating capacity that utilities will need. Renewables democratize energy. We anticipate that the energy transition will be driven largely by mounting concerns about climate change. Climbing oil prices. Restructuring of taxes to incorporate the indirect costs of burning fossil fuels. It is encouraging to know that we now have the technologies to build a new energy economy, one that is not climate disruptive, that does not pollute the air, and that can last as long as the sun itself. The question is no longer whether we can develop a climate stabilizing energy economy, but whether we can develop it before climate change spins out of control.